Hey everybody, welcome back to another C# tutorial for EGG202. You might notice that I have a different version of Visual Studio installed on my machine right now. I'm using Visual Studio 2022, which is actually pretty nice and uses machine learning, I believe, to autofill parts of your code as you write your code, which is definitely a nice feature in this environment. Other than that, though, the actual compilation, the build, runtime environment for C# is not really any different at all. So again, Visual Studio 2019, 2022, even 2017 would actually work for this class and all the C# stuff we're going to be doing for this class. So in this video, what I'm going to be doing is going over arrays. So another sort of concept that you've probably learned in your general C++ courses here at UNLV, but we're going to go over how they're a little different in C#, how they're declared, and how they're passed into functions and so forth. And then we're going to go over a dynamic array structure, which is also possibly similar because in C++ you have vectors. Well, we have that type of structure also in C#. Let's go ahead and begin working on arrays with our C# application with this cone area volume stuff. All right, so I just commented the volume and area formulas above so I don't forget them as I'm sort of working on my programs and calculating area and volume and so forth. So we're going to have an array or a list of different cones, heights, and radii, and we're going to compute the area and volume of each cone element. So I'm not going to really go over two-dimensional arrays, although I could just sort of give a little shout out at the end of this video as to how dynamic two-dimensional arrays work and so forth. But I'm mostly going to work on just one-dimensional arrays. Now I might just at the end give you a two-dimensional array example. So I'm going to first set up my arrays. So I have my const in size equals 5 defined above right here, which is going to allow me to size the array just like you would in 135. So I'm going to just make sure everything's indented correctly. I'm going to say double bracket, and I'm going to say maybe radii equals new double size. So this is the way of declaring. So this declares a reference to an array. This is going to allocate memory to this address. So in C++, I believe in CS202, you introduced that new keyword there. Same idea, we're allocating an array, and we're going to assign this array object to this, not to this pointer, but to this reference. And this type is going to be double bracket, which tells us that this is going to be referenced to an array. A little different in C# than in C++, but nothing too, I don't think it's too complicated at this point. Then we'll have another array, which it already autofills, but I kind of want to call this maybe heights equals new, and then you can see I hit tab twice, it autofills, so it's able to kind of predict what I'm trying to do right there, which is kind of where that machine learning, I guess, comes into play with this autofilling of your code. Okay, so now I have these two arrays declared. They don't contain any data, but they are declared. So now I want to go ahead and write the function to simply read from user input and sort of populate these arrays. So I'm going to create my static function, so static void read input, and of course, just like last time, we're going to have it pass in some prompt message, and then we're going to pass in arrays. I'm going to go ahead and pass them by reference, so double bracket, I'm going to call this maybe just R, and then double bracket, and then I'll call this H for height. I'll make them reference. Now I believe in C#, arrays are actually passed by reference automatically, but I'll just put it as a reference anyway just to be safe, just because I guess it makes sense because we are going to overwrite these in this function. I guess it does, it's more easier to see that by putting a ref in front. That means I'm going to update these arrays. So in this function body, I'm going to sort of read from user 5 lines from the user, and each line will represent a radius and a height of each cone element. Now, of course, I could have made a two-dimensional array instead to do this, but just to make things easier for now, I'm going to make it as a one-dimensional array. All right, so now we're going to prompt the user. So I'm going to have our regular sort of for loop, or counter control loop over here. So for int I equals 0, and I could just go with, instead I'm going to go with just maybe r.length, then I++. So the idea with this is we have the length field. So basically we set the length of this radii array to be 5. So I say r.length is going to return 5. So in C#, arrays are actually objects, not just references like in C++. So you actually can use a length field to access how many elements this array contains. Now, since the radius and height both have the same amount of elements, then we can just simply just use r.length to be able to access both, to have this counter traverse through both the radius and height accordingly. Alrighty, so now I'm going to prompt the user by saying console dot write, so dot write, and I'm going to have it output this prompt message. The autofill is a little annoying right there, but the machine learning sort of autofill is nice at times, but right there was a little annoying. So you first prompt the user to output, to enter this radius and height of a cone, and then we're going to read in this line. So I'm going to have string line equals console dot readline dot split, and use that space as a delimiter. So remember what this does. Remember, from this program, we're going to read in one line. We'll have a number, then a space, another number. So we're going to read that whole line and then separate it by that space, and we're going to return an array of strings. So the first element will be that first number read, and then the second element in this array line will be that second number after that space, just like from the last tutorial video. And now I'm going to simply take our index I, and here's where it's really nice. Is I'm going to hit tab and auto fills it, so it already kind of can predict what I'm trying to do next. So I'm going to take line 0, that first number, convert it into a double, type it in, assign that into this radius index I. Let's see if it works, if the machine learning actually, wow, that's nice. I'm going to hit tab right there, and automatically knew that I was trying to do exactly that for the height. Pretty cool actually, right? So there we are. So now we read in one line, we parsed it, wrote it into R0 and H0, the radius and height, and of course I increments by 1 to the next element and so forth. So that's all there is to this. So I'll run a debugger on this, so you can I can run this sort of line by line, so we can see how debugger can be used to parse a loop as well. But anyway, let's go ahead and just now write our function call in main. So I'm going to say read input, and the prompt message will be enter radius and height. Then we're going to pass the radii by reference. I'm going to say radii, then comma ref heights. Oops. Like that. So just like in C++, we just pass in our string literal into prompt, and we're passing in radii into R and heights into H, and they're both pass reference. So I modify R in this function body, it'll modify back here in main as well. Now I'm going to go ahead and I'm going to try to see if I can sort of, let me see if I can go ahead and maybe put a dummy line right here at the very end, just so I can, say console write line, and maybe keep it blank. I think that shouldn't cause any issues. So I'm going to put I'm going to go ahead and sort of put a breakpoint there, because I want to sort of see what's sorted in my arrays after I'm done. But I'm going to actually put a breakpoint right here as well. Actually, I'll put it up here. So I want to be able to parse this or run a debugger on that function as well, so I can see what's going on. So let's go ahead and just hit F5 to run this in debug mode, so we can get an idea of how this program is working. So F5, we're going to build this, and it's going to run it in debug mode. All right, so let's see what happened here. So I guess that already stopped right there. So okay, no problem. So with debuggers, if you hit F5, it'll just resume the program until it hits the end of the program, or until it hits the next debug line. But right now I'm going to hit F10 actually. F10 will allow us to sort of run this code line by line. So let's hit F10 and see what happens. So it jumps over there. Okay, it sets I equals 0, checks that. And you can see here, if I go ahead and check the prompt, it actually output that because it ran that line. Now I'm going to go ahead and hit F10 again. Now it's going to ask me to enter something. So I'm going to go ahead and enter 5.5 space 6.7, enter. And we see here, you know, looks like everything is working. So the console line returned this. And then if I go ahead and do a split, we see that the split function index 0 contains 5.5 and this one contains string 6.7. So you pass those into their respective arrays right there. So I'm going to hit F10 again, go to the next line. And we can see that when I ran F10, R0 is now updated to 5.5. If I go to age, right now age 0 contains nothing. If I hit F10, we see an update just happen right there. So F10 is a nice way to sort of run your code line by line. So it's a nice, you know, trick. So if you're debugging a program versus doing a bunch of couts or console outputs in C#, a debugger is a very nice, you know, trick. So I'm gonna hit F10 once again, go back to the top of our loop, and okay, again, we can see here outputs that line. I'll hit F10 again. Now it's going to ask me to actually enter, because remember this console read line is sort of going to wait for us to enter some input. I'll put in 10.1 space 15.55 and hit enter. Go back to our debugger and we see here, let me just close these. So let's see, our string split returned this, so our line contains these two strings right there. So it looks like it did correctly parse the string. If I hit, let's go to my R0. So sorry, my R array. So R1 contains 0 right now. If I hit F10, we see an update will happen. Now it contains 10.1 double. If I go to, I'm going to collapse this, go to my H array, it's going to assign something into H1. If I hit F10 again, update happened. So, okay, I think now we can just sort of see it's working. So if I hit F5, it's going to run all my code until it hits the next debug statement or until the program is done. So I'm going to hit F5 right now, which will just now, we're just going to go ahead and run through the program. I'm going to type in 5.55, 6.78, 50.2, space 13.9. I think one more line. Okay, so I'll just try 7.85, 4.22. And now I hit F5 at this point, so now it's going to run to the next either is going to run until it hits the end of the program or until the next breakpoint. So the next breakpoint was right here on this dummy statement. And let's go ahead and check our radii and height arrays. So radii array looks like it has everything correctly inserted. So yep, we can verify for the debugger that everything we wrote here is in those arrays. So perfect. And then looking at our heights array, looks like everything has been inserted just correctly. So I'm going to go ahead and now just hit F5 again, and it'll just end our program because no more break statements after we're done with that. So using our debugger, we can verify that everything was read in correctly into the two respective arrays. Now we're going to go over simply calculating the area and volumes of these shapes, and then eventually go into using the same logic, but we're going to have a dynamic array version instead. Let's get to the actual computing the volume and areas next. Okay, so I'm going to speed this video up a little bit and go straight into lists actually from arrays. So arrays are nice in C#, but really honestly I think a list is a much more useful structure to be able to understand. So I'm going to go straight into having our radii and heights array just be a list type instead, and then we'll have a list to store the areas and the volumes for each cone object. Okay, so I'm going to modify these two structures right here. I'm going to create a list, double, I'll call it radii equals new list double like this. So radii is going to be a dynamic array. So it really does behave similar to an array, but it can be resized. Whereas the previous version that we did, that array was fixed in size. This can be resizable, which is a much more flexible structure versus using a regular array. I'm going to have heights equals new list double, like that. So I'm going to do the same exact thing as before. I'm going to have my dynamic, I'm going to pass them in by reference again, but we're having an error right there because our variables in main, radii and heights, are both lists, but read input expecting to be passing in just a regular array. So it's not going to actually, it's going to be mismatching types. So to fix this, well, I'm going to go ahead and just modify this and just have it as list double. And then same thing for our H will be just list double. Now, I believe once again, you actually can sort of pass it without using ref and it will still work as a reference parameter automatically. But I'm going to go ahead and keep the ref keywords there just that way we're aware that these parameters are indeed passed by reference. So if I modify R and H in this function scope, then back in main, radii and heights will also be modified, just to let me know so I'm not going to be confused as I read through my code. Okay, so now difference I'm going to do over here is instead of having my loop run 5 steps, I'm going to have it where I'm reading in a line, and once an empty line is read in, it'll stop looping. So that way it'll be able to run as many times as needed. So it's going to be able to easily resize the array as we go. So I'm going to do right now, I'm going to, again, this is kind of more of a, how shall we say, more of a sort of a end of file style method of writing this, but this is going to work, of course. So I'm going to go ahead and just output the prompt message to the user. And I'm going to create a string variable, string line, equal console.readLine. So I'm going to read one line in. I'm going to verify if the string is empty. So if it's an empty string, that means I only hit enter, so it read in a blank string. If it has something in the string line, that means I know I read in some line of input, so I'm going to go ahead and process it. So I'm going to have a while loop and just say while line dot, I think it's any. So this is, I guess, the any function is a way of telling us that if it has something in there. So and line.any returns true if there's something in this string, and it returns false if the string is empty. So there's anything in there, I guess. So this is kind of a nice way of being able to verify if a string is empty or not. So if there is anything in this string, let's go ahead and parse this. So I'm going to now create sort of a string array. So wow, look at that. This is actually, I'm going to hit tab twice and automatically knows I'm trying to split this line into 2 strings. So my string split, I'm going to call it split over here. I take this string I read in, dot split. So I want to go ahead and sort of split this by space, just like before. And then split will be the array. So split 0 will contain my first number, and split 1 will make a second number. I'm going to just do the following now. So I'm going to say r dot add. Wow, so it actually auto completed this as well. So there we go, machine learning for the win right there. So this add function is a way to insert something to the back of the list. Very similar to if you've done vectors in C++, there's a pushback function. Same idea here. So we sort of highlight, I'm going to sort of separate this a little bit so we can kind of see this a little better. So right now, I'm taking split 0, which is going to be my first number as a string. I pass it into my double parse function, which will convert this into a decimal or double type. Then I'm going to pass this into my add function, which is going to add this number to the back of this R list. Now let's do the same thing for the height. So wow, it actually auto completes, and hit tab twice. And there we are. So in split index 1 is my second number as a string. I'm going to pass that into my double parse function. Then I'm going to pass that decimal result into my h.add, which means it's going to insert to the back of the vector. And an add function just simply inserts, and then it's going to resize as it inserts. You don't have to worry about setting the size. Add will keep on just pushing elements to the back of the lists. So it's really nice, actually. And then I'm going to again, I'm going to copy this content here and just, again, prompt user for next line. I'm going to now, I'm not going to redefine it, I'm just going to get rid of that string, just not redefine it, but use the same line variable. And then same thing, we just go back and forth until eventually we have until we have an empty line, which will escape this while loop, and it's going to write, it's going to update R and H. So back in main, radii and heights will contain these numbers. So I'm going to go ahead and just do a breakpoint here and see if everything does work correctly. Let's go ahead and just hit F5 to simply run this again in debug mode. All right. So I'm going to go ahead and just maybe read in 3 lines this time. So I'm going to say maybe for first one, be 12.2 space 15.56. Then I'm going to go ahead and try 14.5. Let's say 10.3, and I'll do one more line. So I'll try, let's see, 5.55. Then I'll try 8.79. Okay, so now I'm going to hit just enter by itself, which will be a blank line, which that means the line.any would be false. This right here, this will be false, which means that it will escape this while loop and then jump out of this function and go to main. Let's see what happens. Let's hit enter, and a breakpoint happens, so it stopped right there. So radii and heights, the count is 3 for both, which means 3 numbers were read, which does make sense. Let's go ahead and check out radii. And it contains, let's see here, so it has 12.2, 14.5, 5.55, perfect. Let's look at our heights, let's expand this, and we see here our heights, 15.56, 10.3, 8.79, so it's everything correctly read in. And then we hit a blank line, it stopped, and it escaped out of this, but we saw that we read 3 lines, so it pushed 3 elements to the back of these 2 lists. Now, of course, if I would have done more lines, it would have just simply inserted more elements into them. So really, we can see that the list is a very nice sort of structure. So really, I mean, I guess arrays can be nice. Maybe like in the case like this, we have line 25, we do a string array like this. But in general, a list is really a much better use. There's no point using an array unless there's some specific task that an array might be more convenient. But I would just say a list, you know, always for the win. Just like in C++, a vector always for the win, unless your instructor is telling you to use dynamic arrays and pointers, which I guess that's a bummer, but it is important to learn how pointers work in C++, of course. Anyway, I don't want to ramble on any further. So now let's go ahead and work on computing our volume and areas, and then I could sort of talk a little bit about multidimensional lists and arrays in C#. Okay, so to sort of shorten this video up a little bit again, I'm going to go straight to a function that returns a tuple. So remember from the last video, we had a function return 2 values, the area and the height, and then we used the tuple field to extract the item 1, item 2 in main to get the 2 returns that it returned. So here, I'm going to have our function return a tuple that returns 2 list objects. So in C#, you in fact can return an array or a list as a return type. Now in C++, you can return a vector, you can return a vector type, but an array cannot be returned unless you return a pointer. So in C#, you can see how it's nice and flexible, how we can do all that. Let's go ahead and write our code right here. I'm going to say static. I'm going to return 2 sort of objects. I'm going to return list double, list double. So I'm going to return essentially 2 lists. So one for the area, one for the volume, or vice versa. I'm not sure which one I'm going to go with at the moment. I might go with, I guess, area then volume. So I'm going to go ahead and say get results. Or actually, I mean, I'll call it just compute results. It's probably a better function name. I'm going to have it pass in. So I'm going to first pass in a double, I guess, R, and then list double, let's call it H for right now. There we are. So what I'm going to do right now is I'm going to have sort of a list, double, I'll call this a V for volume, equals new list double. Then I'll have another list, I guess I'm going to call it just A for area. So there we go. So in this function, I'm going to declare these 2 objects, so our volume and area. Then at the end, I'm going to return them. So I'm going to put the return here just so that red line goes away. So return, I guess, v like that. So we're going to return the area and volume back in main. So what I'm going to do right now is I'm going to just simply sort of create the following. So I'm going to go ahead for right now. Actually, no, I can't do it like this. So I'm going to go back to a regular sort of ordinary sort of counter control loop to traverse through radius and height and simply output or simply, calculate those to compute our volumes and areas. So I'm going to have for int I equals 0, I less. I'm going to go ahead and just say maybe r.count. So remember, this count field will tell you how many elements we have stored in that list. And of course, remember, since our h and r, they both contain the same amount of elements, we can just use r.count to tell us how many elements we have to traverse through for our radius and height to be able to compute everything. So I'm going to now, I'm going to go ahead and just sort of, I'm going to copy this code here for the area first. So I'm going to copy this. And we're going to put this here. And again, since our radius and heights are vectors in this case, or list objects in this case, we're going to just use ri, and then we're going to use just again ri over here, and hi. So I'm going to rewrite this a little bit. So we're going to go through every element of, so each radius and each height individually, we're going to go through them, and we're going to compute their sort of area. And at the very end, we're going to say a.add, and we're going to add that. So this entire calculation is going to compute one of the cone object's area by just using the radius and the height. And remember, we're using a list to store all the radii and height. So for each radius and each height, we're going to compute that object's area, and we're going to add that into this vector, or sorry, into this list A. And then the same thing for the volume. I'm going to go ahead and just again copy this. I don't have to memorize this. I can just reuse that. So I'll put this right here. So again, we have to update this a little bit because we're using an array of radius. So ri, and then of course hi like this. And then I'm going to again just say v.add, and we're going to add all of this. So we're going to go ahead and compute. Let's see what happened here. Take a look what's going on in this situation. So operator cannot be applied to operands, avoid an int. Let's see. Oh, I think I missed the parentheses here. There we go. So now what it does is we compute the volume. This is going to be just a computation that computes one of the object's volumes. So we use our I and hi, which represent the same object, the same cone element. We compute this number, and we're going to add it into this vector. And then at the very end, we have our A and V. We inserted the correct number of elements into both lists, and we're going to simply return them. And then we're going to go ahead and just check and see what they contain out here in main. Of course, I have to call the function in main. So I'm going to go ahead and just simply create sort of these two areas and volumes. We're going to create these two objects like this, and then we're going to say, I'm going to then say compute results. I'm going to go ahead and create a variable. So var results equals compute results. I'm going to pass in radii and pass in heights into this function. So what happens here, I'm passing radii and heights. It computes the area and volume of each object, and it's going to return that tuple back to results. And then of course, I'm going to say areas equals results dot item 1, which will be that first element, first tuple. So A is that first tuple. We're going to assign that into areas. And then of course, volumes equals results item 2. So again, item 2 is our second tuple returned by compute results. We're going to assign that into volumes. So there's our code right there. Let's go ahead and just, again, let's just run the debugger on this and see what results we get. So I'll put my breakpoint right there. I'm going to hit F5 to run this in debug mode. And there we are. So I'm entering, again, 3 lines. I'm going to say 13.5, 4.56, 3.48, 6.25. I'm going to do one more line. So I'll have maybe 10.1 and 11.23. Then a blank line. And let's go ahead and check our contents. So I already verified our radii and heights to be correct. Let's look at the areas and volumes. And we see here, I'm going to go ahead and just assume that these are correct, the calculations worked out correctly, but we can see here we're able to populate these 2 arrays because when we go ahead and take items 1, results items 1, it's going to assign a list into areas. It will do a deep copy of this A list, and it will do a deep copy into areas. Then when I do a results item 2, it's going to just take a deep copy of this V a list and assign it into volumes. So looks at areas, has some elements, and then volumes. I'm going to assume that the calculations are correct, so it's able to just create sort of the volume and area of each respective cone with the respective radii and height values. So now another sort of trick, we can of course output these to the screen. So I'll go over a method of outputting or sort of traversing through an array without using just as regular counter control, but using a Foreach type of loop to navigate and traverse through a list. Okay, so I'm going to just simply maybe output just the volumes just to kind of show you how a Foreach loop does work in C#. So I'm going to say for each, and then I'm going to say possibly double, I'll just say, I guess, double area. I can spell area in areas. I'm going to go ahead and just say console.writeLine area. So areas is going to be a list. This also works for arrays as well, because arrays are also kind of lists in a way as well, except they're not dynamic lists. So this loop will go through, so area will be just simply an element in areas. So think of it like this. This is the same exact idea as if I were to have done this. If I say for int I equals 0, I less than areas dot count I plus plus, and console dot writeLine areas I. These two are identical to each other. So here we're iterating through each element using a counter, but this method is sort of a nice, niftier way to traverse through all the elements. So area will really be areas 0, then areas 1, then areas 2. So it's the same idea, except area will be that element that's going to just cycle through all the elements in the array. So you also can, instead, if you want to say, you also in C# can just say var area as well. And it works because when you say var, it's going to assign whatever. So in this case, let's say, for example, on line 57, if I say var results equals compute results, it returns some structure back, and var is going to assign itself to whatever type based on what is returned. So here, var area in areas, so this for each loop iterates to every element in the array. So it knows that area is going to be a list of doubles, so each element in this will be a double, so then var area will really just become double area. But if you don't want to write out double, you don't really want to do all that, it's a nice trick as well, so it can be easier, I guess, to let's say, for example, if this list is a very complicated big structure, then var replaces, writing out the entire, sometimes data structure can be a pretty big type, or the name of the type can be very long sometimes, so var is a nice nifty way around that. Let's go ahead and now just run this, just regular Control F5 to run this in regular mode. So I'll just try 5.55, 7.56. I'll do 2 lines of input this time to be a little faster. 11.2, 13.8, then a blank line. And we see here it output sort of the area of the first cone and the area of the second cone, and the second right here, it output the same thing. So they both worked exactly the same way, except one was maybe a little bit more nifty than the other. But anyway, they both work. So again, there's no really have to traverse through an array using a for each loop. It's just sort of an alternative way of doing that. But the problem is sometimes if you want to iterate through multiple arrays, then I think a for each loop won't really be a good idea, or you can make it work, but it becomes a very complicated style loop. So of course, if you don't mind the challenge, you can look up some syntax as to how to use a for each loop to traverse through multiple arrays at one time. But for now, if you do in fact have to iterate through multiple arrays, then using a regular counter-controlled for loop is, of course, never going to fail you. So now let's go ahead and just talk a little bit about multidimensional arrays in C#. I'm not going to really do any actual sort of code on this, but just so we can see how they're declared, and we can kind of take a look and see how debugger to see how these multidimensional arrays would look like in C#. Okay, so let's go ahead and just create a simple two-dimensional array. This is not going to be related to any of this area and volume of cones, but it's just something on the side just so you can kind of see how it looks. So the syntax for this is actually really bizarre compared to C++. So I'm going to create just an integer two-dimensional array. So I have int, and then comma like this. So we use commas to, so we done like sort of two-dimensional arrays in C++, you have multiple brackets to represent the row index and the column index. In C#, a comma is going to be used to separate that, which is really bizarre, but just sort of work with me on this. I'm going to create, I'll call it matrix for right now, equals new int 4 by 5. So we'll have 4 rows and 5 columns. So basically the data structure, data type for matrix will be this, which means we have a two-dimensional array, and more commas would mean more dimensions you would have, but we'll stick to two-dimensional for right now. And we allocate an array of 4 rows and 5 columns. So to traverse this array, well, I'll just, go back to our normal sort of counter control loop here. So I'm going to say I is less than matrix dot, here's where C# is nice, so dot get length 0. So again, it's a very bizarre syntax. What this does is get length 0 is going to give us sort of the amount of elements in that first field, if you will. So get length 0 is going to give us how many rows this matrix has. Let me go ahead and just put our nested loop right here just so we can kind of see what goes on. Okay, so again, our machine learning helped us out again. So get length 1 is going to tell us how many columns this matrix has. So get length 0 is the amount of rows, and get length 1 is the number of columns. If we had more dimensions then we use get length 2 to give us our third dimension amount, if that makes any sense. So this is our first dimension. This is our second dimension. So get length 0 will give us 4, and get length 1 is going to give us 5, which is our 0 is our 0th or first dimension, and 1 is our second dimension. So that's how we, sort of have that. And of course, I'm going to go ahead and just say matrix I comma j. I'll just assign them all to be, let's say 12. I don't know, just really simple, but that's just a very easy example right there. I'm going to then just again put our dummy statement here at the very end, just so I can sort of stop the program and just look at the debugger and verify what's stored in the matrix. Now, I'm going to, just to make things faster, I'm going to comment out these lines of code. So commenting the same as they are in C++. I don't want to run any of this because I want to just focus on just this part of my code right there. I'm going to put a breakpoint right here and hit F5 to run my program in debug mode. So I already stopped the terminal, but let's go ahead and check this out. So let's look at matrix. And we see here 0, 0, 0, 1, 0, 2 all contain 12, and of course 0, 3, 0, 4, and then our next row 1, 0, 1, 1, 1, 2. So looks like everything is correctly assigned in there. So not really too much interesting stuff going on there, but just we want to see how to declare and allocate a two-dimensional array and how to navigate through it. So again, I don't believe a for each loop could really be very nifty to work with in C#. So with two-dimensional arrays, at least not in the older version of C#. But right now, this is sort of the standard way to sort of traverse through a two-dimensional array. Now let's go ahead and sort of look at two-dimensional list structures next. Okay, just to speed this up, I wrote some code already and tested it out. So there might be other ways you can look up code to be able to do this, but to have a two-dimensional list, you simply just have to have a list of lists is the idea. So we have this matrix, we have a list of lists. So remember, for a two-dimensional array, we have sort of our amount of rows. Each row has a set of numbers, which is going to be, I guess, our columns, if you will. So outer list will be our list of rows, inner list will be the actual elements in each row. So we have to allocate it to a new object like this. So I want to have 4 rows. So I'm going to have this loop right there. That's going to be a counter control loop that runs 4 times. This inner loop is this inner content will actually build each row 1 row at a time. So I'm going to create an object right here, call it row. I'm going to add 5 elements or 5 zeros. I'm going to add to this. So this is going to be an array that contains 5 zeros. I'm going to add this into our matrix, which means it's going to add 1 row. So our first row contains all zeros, and then of course the next row will contain also all zeros, and so forth. So again, it's going to be just our nifty trick to be able to insert 1 row at a time like this. And then this loop right there, we're going to simply output to the screen each element. So it's not going to output it very nicely, but right here we have this for each loop, which with arrays, I don't think you can do this, but with this list of lists, I believe you can. So you have a for each loop, and we're going to iterate through each row. So var row in matrix, so it's going to be 1 array. And then we're going to have this var element will iterate through each element in that row. And we're going to go ahead and output the element at the very end like that. Now, of course, we can also use a regular counter control loop way of doing this as well. I'm going to put an extra output statement here, just output a blank line. And then I'm going to write the same exact sort of code, but in this regular C++-ish type of way. So we're going to say matrix dot count like this. They'll have for int j equals 0, j less than matrix I dot count, and j plus plus, and of course do a console dot write line matrix ij. So this is actually nice because using this list of lists version, now it looks very similar to C++ in terms of how to index the array. So these two loops are the same exact thing. So a row is going to be just simply a list, a row from this matrix, and this other inner loop will iterate through each element in that row. So these two loops are identical to each other. Let's go ahead and just simply run this, not in debug mode, but in regular mode, just to kind of see how this works. So Control F5. And outputs all zeros because, well, they're all zeros in our structure. Now let's go ahead and just run this in debug mode and just check. So I'm going to put a debug statement right here actually, so we can kind of see what's inside the matrix, once we initialize and allocate the memory to it. So F5 will run this in debug mode. Let's go ahead and check. So matrix has sort of 4 rows. Each row has 5 elements, and then each one has all zeros. So looks like it is working. It's a little bit different structure because it's going to be sort of a reference that refers from a row to a column and so forth. But anyway, that's sort of the method of being able to allocate a two-dimensional sort of list. Now, of course, for our assignments, if you do in fact encounter a two-dimensional array, I would just say if this is a little bit too confusing, you can of course just refer to two-dimensional arrays and not have to refer to two-dimensional lists. But this is really, you can of course use this code on that. So anyway, this video just went ahead and covered just arrays and lists and functions involving arrays and lists in C#. So hopefully this video does sort of give you some insight as to how arrays are similar but yet a little different in C# and C++. So I guess that's it for this video. Take care, you guys. Stay safe as always, and until next time.